All right, hey everybody, this is Coach Low back with you. We're going to do experiments versus observations today, specifically designing experiments. And hope you're doing well. All right, let's get through it. We got a lot of vocabulary. All right, so let me get along. Let's go big. Let's do that strange color. All right, here we go. So, an experiment deliberately imposes treatments on individuals to measure their response. Very important. So that's an experiment. Treatment is specifically what each individual in the experiment is assigned to do. So that's the plan. That's exactly what's doing from start to finish. Who's doing what? Control. What condition is exactly the same in each trial? And basically they're saying the more you control, that means the less, I guess, likelihood that your results will be due to something else, okay? So like if you really want to zero in on if something does make a difference, then you need to limit, this outside interference. So you want to work on the controls. Better examples coming up. Explanatory variable is what is deliberately changed to see if the change causes a response. So what are you actually changing in this experiment? Response, of course, is going to be how you measure it, the outcome. And then you got observational studies, a study that uses available data, and it does not impose treatments. All right, so it does not impose treatments. And that's, of course, the big difference between observational studies and then experiments. More vocab here. So the subjects will be those who are receiving the treatment. And then you got two options right here for blind and double blind. If the subject does not know which treatment they are getting, then that's considered blind. If neither the subject nor the people collecting the data know which treatment it is or what the treatment is, then that's considered double blind. Okay? All right, good example. And I need to get one of these for my face. All right, example. Does creating a distracting atmosphere affect players' performance on a free throw? So we've seen this a lot in basketball games. You get the crazies back there. Does it affect this guy, the one that's shooting the ball at the free throw line? So here we go. Treatment is going to be, let's assign half the players to shoot free throws in a distracted environment. So there you go. You get the crazies right in front of them. And then the other half is going to shoot in a distracted free environment. So half are going to be shooting with the crazies in front of them, and half of them are going to be shooting in a quiet environment. So things to control. Make sure the same size ball could make a difference, right? Does it matter the same heights? Basically, you want similar basketball players, similar skill. I mean, that could all be thrown in here with control. Explanatory. So what are you actually changing in this? And that's going to be the type of environment. You're going from the rowdy crowd to the quiet crowd. So the type environment will be the explanatory variable. And then a response variable, you're going to measure this by, I guess, makes or misses. Okay. All right. Let's move it on. All right, here we go. Stephen is watching a baseball game. He is counting how many strikes were thrown when the count is 3-1. He records that data and then analyzes it to make a decision about the pressure of pitching. So this is going to be considered observational. Even though he's getting numbers here, but he's not imposing a treatment. So therefore, it's not an experiment. So that is an observational study. Moving on. All right. So, experiment or observation. So, in a study, a group of mice are given an injection of a drug proposed to shrink lung tumors. After 1 month, the tumor sizes are recorded. So, is this observation or is it experiment? So, since you're actually imposing this treatment, which is an injection, that is your treatment. Okay? You're imposing a treatment. That's going to make this an experiment. Bob proposed that the more you exercise, the more likely you are to be promoted at your job. Interesting. He reviewed the exercise regimens of coworkers who were promoted and those who were not. Since he's not imposing a treatment, This is going to be an observation. And then P, to record the reactions of everyone in a movie theater during the ending of Endgame. So he's just taking it all in. That's just going to be another example of observation. Again, no treatment was imposed. All right, here we go. Now, when they start breaking into a situation like this, you want to make sure you get in here, read it a couple of times, make sure you get your details. So, does caffeine increase pulse rate? So, a statistics class, go figure, 20 students, that's probably important, so I'm going to go ahead and underline that. Designed an experiment to find out, all right? So, does caffeine increase pulse rates? So, they're going to take half of those 20 and they're going to be assigned to drink cola with caffeine. And then the other half are going to be assigned to drink caffeine-free. Caffeine-free cola. So before the students consume the beverage, they measure their initial pulse rates. Then 10 minutes after they finish their beverage, they're going to measure those pulse rates again. Then they're going to calculate that change in pulse rates. So experimental observational study right off the bat, definitely they're imposing a treatment. So we'll go ahead and underline experiment. Okay, so again, they are imposing a treatment. All right, so what was the exact treatment? So we had to lay out the plan here. So 20 students total. I'm going to start here. So we got 20 students. And then we're going to split them up. So that means 10 are going to be getting the caffeine. And the other 10 are going to be getting caffeine free, or I'm just going to put no caffeine. No caffeine. Okay, so then we're going to get their pulse rates before and after. Before and after, and then find the difference. And then we'll find the difference. Difference in rates. So that's sort of the game plan. All right, things to control. Well, caffeine does affect different people differently. So I'm going to throw in just a couple here. Does body type matter? Probably so. Okay. What they ate for breakfast might matter. Everything. What about sleep that night? There's a couple things that could make a difference. And you also want to make sure their pulse rates were pretty much the same before. So how would I say that? Same. Same lead up. Same pregame. I'm just going to go pregame. Okay. And when I say pregame, that's pretty general. I'm just saying all these people need to be doing basically the same things. They probably need to be sitting at a desk or something like that for 20, 30 minutes before. That way everybody's starting from the same spot as best we can. All right, explanatory. What are we changing? That's going to be the caffeine. And is this blind? It doesn't really say that they hid which type of cola, but it definitely could be. And I'm going to put yes, possibly. Because think about it, they could put them in little bitty cups with cola, and each one of those students does not know what they're getting. So I'm just going to put yes, possibly. And it could be double blind for that matter. If you mix it up, have it assigned to numbers, it could definitely be double blind. They didn't mention it, but definitely it could be. All right, here we go. Next example, do name brand trash bags hold more weight than store brand trash bags? Two statistics students, here comes Janelle and Brittany, decided to test it out. So to do so, they randomly selected 15 Glad trash bags, 15 Walmart trash bags. They're going to load them down with oranges until they break. So experiment or observation, since they're imposing a treatment, here we go again, definitely experiment. Let me go back, imposing a treatment. So what is the actual treatment? Who's doing what? So we're going to take 15 Glad bags. We're going to take 15 Walmart. And then we're basically going to add oranges until they break. All right, so what can we control? Let's see here, not all oranges are the same, so I'm just going to put the size of the orange maybe. And then how the oranges are placed in the bag maybe? Because what if they're thrown, or are they just set in there? Placed in the bag. Dot, dot, dot. Okay, explanatory variable. So what are we changing out? That is the bag type. Sounds more professional. And then response, how we're going to measure it. You could either go by pounds, maybe. They didn't mention it. Or assuming they're all similar in size, oranges, you could say number of oranges. Maybe they need to go with something a little bit more uniform, like baseballs or softballs or something like that. Okay, so blind. Could this be blind? You take the bags out of the bag. A lot of times they look the same. So I'm going to put yes, possibly. And if you were to assign them numbers, you could, kind of like the last example, do double blind. Sky's the limit on this one. So anyway, that's your intro into experiments and observations. I hope you enjoyed it. Hope all is well. Good luck.